So let's come back to this circle, this unit circle. And you can see what we've done here now is we still have our radian angle that we're moving through, and we have our radius. And what we're going to do is start looking at, okay, how can we divide this circle up into some meaningful radian measure that we can equate to later our degree measure. So if we start off at where the arrowhead is at the 3 o'clock position, that will be 0 radians, okay, or 0 degrees, but in this case 0 radians. And now the next thing we want to do is move the radius, the clock hand, okay, if you will, through 90 degrees. So in this case, when we move the clock hand straight up, we are at pi over 2 radians. Well, let's step forward one more time. If we move it exactly 180 degrees, or in the negative direction, you see we have pi radians, okay? So now if we think back, if we go back then to pi over 2 radians, you can see that what we've done is we have moved through pi over 2 radians, or half of the distance. Okay, and so now we do the same thing one more time. We're going to move the hand past pi radians to 3 pi over 2 radians, or 3/2 of the way around. And then one more time completes the circle, the radius, if you will, of 2 pi radians. So now when we do this, we can see how we have divided the circle, in this case, into fourths. And each of those fourths is really a measure of pi over 2, or half pi radians. If we were to move it just to here, okay, we would end up with, in essence, our 45-degree angle. And so we're going to look at what the measure would be from here to here in radians. Okay, so now you can see when we do that, we've gone from 0 radians now to pi over 4 radians, and then 2 pi over 4, which is pi over 2 radians, and then 3 pi over 4 radians, and then 4 pi over 4 radians, which is pi radians, 5 pi over 4 radians, 6 pi over 4 radians, which is 3 pi over 2 radians, 7 pi over 4 radians, and then 8 pi over 4 radians, which is 2 pi. So we can keep dividing this up into as many radians with respect to pi as we deem necessary. So as I said, each one of these radian values, of course, has a degree value associated with it. So what we have to do then is we have to, as we move counterclockwise around the circle, degree and pi radian wise, we have to come up with some sort of conversion factor, and we're going to do that so that we know how to convert from pi over 4 radians to 45 degrees. Okay, so why would we do this? Well, there are cases in radian measurements where we need a radian angle to do the analysis rather than a degree angle, because we start to get into this rotational motion. So how do we make this transition or this conversion? Well, we've already seen that 1 radian is defined as 360 degrees divided by 2 pi. And when we divide 2 pi into 360, we will get 57.3 degrees. So now we have a new value here for 1 radian, 57.3. So if you think back to our circle, let's go back here. Here's 45, here's 90. So somewhere out here beyond 45 degrees is going to be our measure of 57.3 degrees, or 1 radian. So theta in radians is equal to pi over 180 degrees. Okay, So we're going to develop then a relationship of the angle to our degree measures. So if we want to convert 45 degrees to radians, the conversion then becomes a matter of pi over 180 times the degrees of interest that we're looking at. So to determine pi in radius of 45 degrees, we multiply it times pi and divide by 180 degrees. So 45 degrees over 180 degrees times pi gives us a value of 4 pi radians. So you'll get used to doing this as we move through the examples. Let's convert 60 degrees to radians. So we've got our relationship. We're going to convert to radians, 60 degrees. So theta is equal to 60 degrees times pi divided by 180, which gives us now pi over 3 radians. If we want to convert pi over 6 radians to degrees, now we multiply pi over 6 times 180. We invert it, you see, over pi. The pi's cancel out. And so we have 6 divided into 180, which gives us 30 degrees. So now what we need to start looking at is how do we relate linear displacement, where we've used values of x and y, into an angular displacement where we use theta now, our angle.